All right, this is the last lesson of Topic B for Module 6, Lesson 15, 7th grade. So we're talking about those unique triangles and trying to use them more in a real-world situation. A lot of times we think, okay, when am I ever going to use geometry? Actually, quite a bit. All right, so let's go ahead and pull this up. So we have this triangular fence here. They're telling us that angle S matches or is equal to angle T. So I'm going to make those there. Now, this was all to enclose these sheep. The fence is constructed of the triangle that exactly cuts the other angle into two equal parts. So this is going to be equal to that. Therefore, SRW, this whole angle here, SRW is equal to TRW. So these two angles out here are equal. I'm actually going to make double arcs on those because I already have a single arc. And we know that SW is the same as WT because they told us they cut it in half, which made two equal sides. So what they want to know here is, what do you have? So we're going to say, we know that angle S equals angle T. So therefore, one pair of sides with equal lengths. All right, so we have two angle measures that are confirmed, and we also have two sides that are confirmed with equal lengths. And then with that all confirmed, we can say that these two angles back here are equal. That's all they want you to put. All right, let's try the next one. I have these two triangles here. Now, if you're looking here, I have these tack marks, which means these two side lengths are the same. So let's say that was 4, this would be 4, that would be 4, this would be 4. They're all 4, let's just say. All right, now let's read the directions here. AC is the same as BC. Okay, those are those tack marks. Now, if you see, these ones have a little 1. That's because this is A1, C1, and B1, okay? So triangle ABC matches BAC. Oh, do you see that? They going in an opposite direction. Let me do this in a different color. Triangle ABC means you start at the A, you go to B, and then I'm going to come up here and go to C. That's how they're classifying that triangle. But look at how they classified this triangle. They started at B, and they went to A, and then they went to C, which is fine as long as my angles all match up. So then they say, John says the triangle corresponds to two matches two sides. Yep, check. We have tack marks, so we have two sides that match, of course. And an included angle, which means it needs to touch. That is angle A and angle B. All right. Is that just regular B? Nope, it is a B1. I just wanted to make sure. I kind of colored over it there. So they're saying angle A is the same as B1. Is that true? All right, let's see. Again, angle A going in this direction. Angle B going in this direction. Are they the same? Yes, they are. So we're going to say, yes, John is correct. Those two are matches. Those two do correspond. All right, let's try the next one. Now, I know we're not using compasses in class, but we can kind of follow along with what this person did here. It says, Mary puts the center of her compass at the vertex of O of an angle and locates points A and B. So she put her compass here, and then she kind of spun it. And here's A, and here's B. Okay? So she made those 2 points on those lines. Next, she centers her compass at each of those points. So now she puts her compass here, and she's moving it this way to locate C. So she moves it and comes out here and gets C, which is out here. So now she has these points all here. These 4 points now. So she went from 3 points to 4 points with her compass. And then she connects this to the vertex. So she has this sort of looking thing. So if I connected all of these lines, I wind up with something like that. Okay, kind of like a diamond in the center. So the question here is, finally she connects the ray OC. Explain why BOC, I'm going to get a different color here. Explain why BOC, why does this angle match AOC? Why did they match? So let's write up our reasoning. We're going to say angle BOC equals angle AOC because triangle OBC corresponds to triangle OAC, because I have actual two triangles here, that matches 3 pairs of equal sides. I have this one matches this one matches this one, and then my common side in the middle. So my 3 pairs of equal sides, period. So therefore, the triangles are identical. And if all the sides have a match, then the triangle is identical. All right, let's look at number 2. So here's the kite, very similar to what we just did up above. Okay, remember we brought it out to that one point. We have kites here. All right. Now, this is actually 2 tack marks. It's just very hard to see, so I'm going to go ahead and darken that up a little bit. These are 1 tack marks. All right. Now, what can we say? We can say what's equal. We can say line AC is equal to line BC because we have tack marks there. We can also say line AD is equal to line BD, and those are those 2 tack marks. So we have that information here. And what do we know about this going right down the middle? That is a common side. So obviously they have that in common. So we're going to say line CD is a common side, which makes those equal. So therefore, can you use identical triangles to show John is correct? So remember up above we said yes, he was correct. Well, here's an actual picture of his kite. So we're going to say that triangle ACD corresponds to triangle BCD. Reasoning, 3 pairs of equal sides. So the triangles are identical. Just basically what we said up above. They're just showing you an actual picture of a real life thing versus the drawing with the compass. All right, let's go on to the back. All right, so this will be the last one I do with you here. So try, B and C. And then you guys are going to do 3 and 4 and 4B. Jill says that there are 2 sticks that are perpendicular to each other. Use the fact that angle ACD and angle BCD and what you know about identical triangles, can that prove that angle AEC is a 90 degrees? So I'm going to go back up here to the picture. She is saying, okay, so she's trying to prove that you get a 90 degree at AEC. Is that a 90 degree angle? And how can we prove it? That's what we want to prove, is that that does come out to a perfect 90. All right, so now let's go back to the question. All right, so what we do know is that AC was equal to line BC. Therefore, angle ACD corresponded or equaled angle BCD. So just because they told me that right there. And that there was that common side of CE was a common side. Now I shortened it because of course it was CD before, but we're just caring about that top part. So putting that all together, we can say, since both angles are adjacent, which means between, are adjacent to each other, on a straight line, their measures sum is 180. Therefore, each angle is 90 because it's cut right in half. There you go. We just proved it. C. John says that Jill's triangle correspondence that shows the sticks are perpendicular to each other also shows that the sticks cross at a midpoint of the horizontal stick. Is he correct? So, if you're looking at the picture, oops, let me get rid of that. If you're looking at the picture of the kite, all right, we just proved, let me take this away right here. We just proved that these are 90s because this whole thing is 180. And if I cut that in half, I create two 90s because it's perpendicular. So now John is saying, could E be a midpoint? Is this classified as a midpoint? Is it midway through that angle? All right, so that's what we're going to classify now, all right, or prove. Let me just pull it all the way up. Okay, so we're going to say this means, is he correct? We're going to say yes, because this means E dot vertex E is the midpoint of line AB. So yes, John is correct. All right, so I'm going to have you do 3, 4, and 4B, and those will be ones that I grade. All right, so that ends this video tutorial.